Hello friends, this time I want us to look at vector geometry. Okay, so under vector geometry, the first question that we are going to look at is the question that we have here. It's always important to read the question and you look at the diagram that you have. So in the question, we have in the diagram below OABC. OABC is a parallelogram in which OA is equal to 2A. So from O up to A there, you have 2A. And OC is equal to 2B. So from O here up to C there, you have 2B. P is a point on OA such that OP, so from O up to P there, OP is equal to a quarter of OA. So OA is that one, and from O to P we are told that it's just a quarter of the whole thing. And Q is a point on CB such that CQ to QB is 3 to 1. So from C to Q and Q to B, the ratio is 3 to 1. Okay, so we are going to try and answer these questions that we have here. Express in terms of A and OB. Okay, so we have OB here, we have OP, we have QC, and then we have the other questions. Okay, so now here, one thing that we need to note here is that we are dealing with a parallelogram. So what you have under here, OC, is the same as AB, and OA is the same as CB. Okay, so and you have to make sure you take note of the arrows and the direction in which they are pointing. Okay, so let's start with our question. So our question, which is question 1A, which says find OB. Find OB. So the first thing that you do here, you are finding OB, is to write the formula for OB. So to move from O to B, there are two ways in which we can go. We can either move from O to A and then A to B, or we can move from O to C and C to B. So I'm going to use the root for OA plus AB. Okay, so from O to A and A to B. And then there we are just going to replace now the vectors that we have. So we are given to say that from O to A, the vector is 2A. So we are going to have here 2A plus from A to B, the vector of AB is the same as OC. Since it's a parallelogram, opposite sides are the same. So OC is 2B, it means that AB is also 2B. So we are going to have 2B here, and this gives us the answer for the first question. This gives us the solution for the first question for OB. So OB is equal to 2A plus 2B. And then we go to part B of our question. Okay, so in part B, the question says find OP. Find OP. Okay, so here, OP is from here up to here. So now in the question, we are given that OP is equal to 1 over 4 OA. So I'll write it here, a quarter of OA. Okay, so we can see here that OA has also been given. It's 2A, here it is. You can also get it from the question, OA is equal to 2A. So we are going to replace there. So we are going to have 1 over 4 times 2A. Okay, so we can multiply here. We are going to have 1 times 2A. Remember, you can put it as over 1 if you want. So you are going to have 1 times 2A here. You are going to have 2A over 4. 4 times 1 is 4. And then you can cancel there, 2 there. You are going to have 1 over 2 there. You are going to have 2A. And so this is OP. So find QC. So B here. B says find QC. Okay, so finding QC, you can write a formula for QC, but you are going to run into some problems. So for example, if you want to write a formula for QC, you can write it as QP PO plus OC, but you're going to have a lot of problems but there's we have a ratio here that we can use. We have a ratio that we can use. We've been given that CQ to QB is equal to 3 to 1. CQ to QB is equal to 3 to 1. So CQ to QB is equal to 3 to 1. So here we can use this ratio to find QC, because as you can see here, it's just the letters that have been swapped here. They've been interchanged. Here in the ratio we have CQ, but the question says find QC. Okay, so here is how we find. And so the way we find, the first thing that we do is, since Q is between C and B, the first thing that you do is to add the ratios. Add the ratios. So you're going to have 3 plus 1, you get 4. And so CQ, which will help us to find QC, will be equal to, remember in this ratio, CQ is represented by 3. So you're going to have 3 over the total that we found here, 4, by CB. Okay? Because here, as you can see, Q is in between C and B. So the formula is going to be 3 over 4 times CB. Okay, so now remember the question is saying find QC. So from this we can find QC, and what we are going to do now is we'll say therefore QC will be equal to, and then all you do is now you just put a negative here, negative 3 over 4, since you've now changed the direction. It was supposed to be CQ according to the ratio, but now the question says find QC, so the direction has changed from C to Q. Now it's Q to C, so you have to put a negative negative sign that shows a change in direction. CB. Okay, CB here, CB is the same as OA. So 2A, this side, it means you also have 2A here. So you're going to substitute here. You're going to have negative 3 over 4 times 2A. So we multiply these two here. We are going to have 3 times 2, negative 3 times 2. You're going to have negative 6 over 4A. And so 2 can go into 6 3 times. You are going to have 3, negative 3 here, over 2 into 4, you have 2A. And so therefore our QC here is negative 3 over 2A. So question 2, given that OX is equal to HOB. Okay, so what you do now here is we already have OB here in the question. We found OB here. Let me show you in the first question that we found OB. So here is our OB here. OB is equal to OA plus AB, and we got 2A plus 2B. So what we are going to do now is we are going to substitute here. We'll write H, and where there's OB here, we'll open brackets and write what we got here, 2A plus 2B. So we are going to have 2A plus 2B. And then we'll expand the brackets here. We are going to multiply H times 2A. We are going to have 2HA. So it's always important to write the vectors like this. Write the vector at the end. Plus H times 2B. You are going to have 2HB. So we have written our vector OX in terms of A, B, and H. Okay, so now we go to part 3 of the question. Question 3. Okay, question 3 says, hence show that Px is equal to a half of 4h minus 1a plus 2hb. So what we are going to do here, the word hence here means that what you found here, use it here. So we are going to write the formula for Px. So Px is equal to PO plus OX. Okay, so we are using our OX here, it is, and then PO. So PX, you come to your diagram here, P is here, X is there. So the way you move around the diagram to get to X, you are going to move PO plus OX. Okay, of course you can move in other directions. If you decide to go PA plus AB plus BX, the problem is that you do not have BX here. So use what you have when you are dealing with vectors to find what you don't have. So we have OP we got. So we can find PO. So PO plus OX, and then we are going to solve. So here we are. Now when we look at our equation here, PO we found in our in question 1 part B here, we found OP. We found OP is equal to 1 over 2A. Okay, and our equation says that we should use PO. So we have changed the direction from OP that we got. Now we are changing the direction to PO. So what you do when the direction changes is that you just put a negative, which shows that direction has changed. So here we are going to have a negative 1 over 2A plus OX is what we got here. Our OX is 2HA plus 2HB. So we are going to have 2 here, HA plus 2HB. Okay, so here now at this stage, we already have like terms here. We have A here and we have A there. So all we can do now is just to rewrite this. We are going to have 2HA minus half of A plus 2HB. Okay, so the next step now is just to factorize. Now factorizing this is something that is simple. You can write these two under the same common denominator. Okay, let me write them under the same common denominator. Let me write this one over 1, and the common denominator here will be 2 for this one and this one. So 1 into 2 is 2. 2 times 2, you are going to have 4 HA minus 1. Okay, you can have minus 1A here plus 2HB. So we can factorize here now. Here we can factorize. As you can see, this one can easily be factorized. The 1 over 2 can be taken outside here. You're going to have half. And then in the brackets, you are going to remain with 4H minus this one here. Okay, the A is also common, so it will come outside, plus 2HB. And here we can even write and say hence shown. So we have shown that Px is equal to this vector here. So this is the end of our lesson. Thank you for paying attention.